Hello everyone, welcome to PM Networking. Hope you all are doing great. Guys, today in this video we are going to understand STP protection. Guys, one of my paid student has requested me to make one video on STP protection. So today in this video we are going to cover some features that help to protect STP network, a spanning tree network. See what features we are going to learn in this video. Guys, features like root guard, loop guard, BPDU guard and BPDU filter. These features are very important to protect STP network and we are using these features in real time. So guys, if you are a network engineer and you want to learn these all features, make sure you will watch this video till the end. Or if you are planning to become a network engineer, right, make sure you will learn these all features, guys, because anyone can ask you question from these features, because these are, as I told you, these are very important and we are using it nowadays in real time. So interviewer can also ask you like what is root guard, how root guard works, how to protect a root bridge switch, right? What is loop guard, what is BPDU guard, what is BPDU filter, how BPDU filter work, how root guard work, how loop guard work, how BPDU guard work, like this. Okay, so guys, after watching this video you will have a strong knowledge about these all features like root guard, loop guard, BPDU guard and BPDU filter. You can answer to interviewer, you can configure it in the real time, and you will have the understanding of working of each features, like how these features are going to work. Okay, so I am going to show you theory as well as practical. So I have the same topology, guys, in EVNG. You can see in my topology I have three switches: switch 1, switch 2 and switch 3. First of all, let me make you familiar with this topology and then we will start the session. So guys, in my topology you can see I have three switches and all switches priority is default. Priority is default means 32768 on all switches. That means root bridge election is going to happen on the basis of what? On the basis of base MAC address. On the basis of base MAC address. And you can see base MAC address of switch 1 is this one, base MAC address of switch 2 is this one, base MAC address of switch 3 is this one, right? So according to you, tell me which switch will become root bridge in this scenario. Definitely switch 1, because priority on all switches is same and switch 1 have lower base MAC address, so switch 1 is going to become root bridge. And as you know, all ports of root bridge will be what? DP, DP, DP. This port will be your RP, this port will be your RP. On this segment, one port will become DP and one port will become what? Alternate, like this. This is our loop free STP topology. So if you want to verify it like switch 1 is my root bridge or not, you can do what? You can run command show a spanning tree on switch number 1. So let me access switch 1 here, and on switch number 1 I'm going to just run this command, enable show a spanning tree. So yes, you can see this switch is, this bridge is the root. Switch 1 is your root bridge, and bridge ID and root bridge ID of this switches you can see same, right? This is base MAC address of switch 1. And as here we are running PVST, note common spanning tree protocol. That's why you are able to see priority is what? 32769, not 8. 32768 plus 1 VLAN ID. Okay, so this is priority. Here what is type of spanning tree protocol we are running? For that, what command I can run? So spanning tree summary. You can see here we are running PVST mode. Okay, now guys, on switch number 2 also you can verify which switch is root bridge. This is switch 3. Let me access switch 1, switch 2. So spanning tree. Yes, you can see the bridge. Root bridge is switch 1. This is base MAC address of switch 1. Switch 1 is my root bridge and this is bridge ID of switch 2. Okay, so this is bridge ID and this is root bridge ID. Correct? So in the root bridge ID you can see the base MAC address is the MAC address of switch 1, right? In the same way guys, on switch number 3 also you can verify it, that which switch is root bridge. So a spanning tree. Yes, this is again what? Root bridge ID and this is what? Bridge ID. So in the root bridge ID you can see the MAC address. This is MAC address of switch 1. That means on switch number 2 also, switch number 3 also, and on switch number 1 also we have verified that switch 1 is your root bridge switch. Fine. And there is one switch here. You can see this is, just assume that attacker, this is attacker. Attacker can send superior BPDU, and we will see how this attacker can attack in this network, and they can means disturb this network, right? And how to prevent all types of attacks, all types of possible attacks with the help of these features. Fine. So now let's begin without wasting our time. Let's start. Let's understand from first one, that is root guard. Now what is root guard? Guys, root guard is a spanning tree feature which is used to prevent, which is used to not prevent, you can say which is used to protect root bridge switch, which is used to protect root bridge switch. Like in this scenario, switch 1 is my root bridge switch, correct? So this port is what, DP, this port is DP. Now guys, just assume that there is one attacker, this is switch of attacker, and they have set priority what, they are 0. And if this attacker is going to connect their switch to root bridge, now what will happen in this scenario? This switch is going to send what, superior BPDU, because this switch have priority what, 0, and on switch number 1 priority is what, 32768. Or doesn't matter where is attacker, right? Maybe attacker is connected with switch number 2 here, and this attacker can generate a superior BPDU. It will forward to switch 2, switch 2 will forward to switch 1, and on switch 1 will receive superior BPDU on this port. This port will become what, RP. This port will become RP, and after that switch 1 is going to declare their self that I am not root bridge. So let's say this is attacker switch, and if this attacker will send a superior BPDU to switch number 1, so this interface is receiving superior BPDU, so this port will become what, RP. Earlier all ports of root bridge switch will be what, DP, guys, was what, DP. But now one port of root bridge is what, RP, because it is receiving superior BPDU over here. And once a root bridge switch will receive superior BPDU, it is going to declare their self as non-root bridge switch. So just to prevent this attack, to protect my root bridge, we are using this feature called root guard. What root guard feature will do here? Once we will enable root guard on DP port, we always enable root guard feature on DP port, designated port, right? So let's say root guard feature is enabled on all ports of root bridge switch, right? So this port is DP and root guard feature is enabled. Now if attacker will send superior BPDU, root guard will not allow this port to become RP from DP, right? So root guard feature is not going to allow any DP port to become what, RP port, root port, even it is receiving a superior BPDU, right? So let's say in this scenario, this is my DP port, and switch 1, switch 2 is sending one superior BPDU, right? Attacker is sending one superior BPDU on 0/0 interface. If root guard feature is not enabled, then this port will become RP. If root guard feature is enabled over here, this port will not become RP. Simply root guard will put this interface into a root inconsistent state. Always keep in mind, whenever a root guard enabled interface receives superior BPDU, it will put that interface into root inconsistent state. And root inconsistent state is similar like blocking state. Okay, so if you want to learn more about the root guard, here I have written the definition in very easy language so that anyone can understand. Like you can see, root guard is a feature in a spanning tree protocol that helps to prevent a designated port from becoming the root port. What I am saying, helps to prevent a designated port from becoming the root port. It is used to protect the integrity of STP topology by ensuring that a designated port does not become a root port even it receives superior BPDU from a neighboring switch, right? So hope now it is clear to you. Like this is my root bridge switch, and this switch is connected with one neighboring switch, let's say 2, and if this port is DP, if this switch, root bridge switch, is receiving a BPDU, superior BPDU on DP port, root guard feature will not allow this port to become RP, right? And it will put that interface in root inconsistent state. Here you can read, if a switch port with root guard enabled receives superior BPDUs, it will put that port into root inconsistent state, effectively blocking the port and preventing it from participating in the forwarding process until the superior BPDUs stop, right? So until and unless root bridge switch is receiving a superior BPDU on their DP port, it will put that port into root inconsistent state until superior BPDU not stop. This helps to maintain a stable STP topology by avoiding unintended change to the root bridge. Getting my point? Right? Then guys, you can learn more about it, like root guard adds an extra layer of protection to STP network by guarding against unexpected root bridge change caused by misconfiguration or intentional malicious action. It can be because of misconfiguration also, right? Let's say someone have set priority 0 on switch number 2 by mistaken. So switch 2 is going to send the superior BPDU to switch number 1, right? But in my network, switch 1 should be my root bridge, right? So root guard is going to add one extra layer of protection here. It is going to start guarding this interface, that whenever this interface will receive superior BPDU, I will put that interface into root inconsistent state, right? Unexpected means because we never expect that we will receive superior BPDU on the root bridge interface, root bridge switch ports, because root bridge ports will always transmit the superior BPDU, will never receive the superior BPDUs, right? So that's why we are saying unexpected. Now what is the command to configure it? Guys, simply on the interface you can run this command, spanning tree root guard. That's it. Now let me show you one practical of it, like how attacker can attack in the network and then how we can prevent it through a spanning tree protocol. So I'm going to connect attacker switch to switch number 1. Before that I will configure attacker switch, and let me do one thing. Let me turn off switch number 1 and let me connect these two switches first together, right? Then I am going to turn on switch number attacker switch. I'm first going to down this interface, E0/0 interface, right? Shut down, so that it will not send any traffic, any BPDU. Host name attacker, done. Now interface E0/0 says shut down. That's it. Now I'm going to turn on switch number 1. Okay, so this is my stable topology. This is my stable topology till now, right? Everything is working fine. Switch 1 is my root bridge, and switch 2, switch 3, these switches are non-root bridge switch. Fine. To verify it, you have access of all switches, you can verify it. Enable a spanning tree, so a spanning tree, so a spanning tree, right? So this bridge is the root. What happened? Correct. Now I am going to configure the attacker switch. See, first of all I am going to set priority 0 over here, right? So that this switch should become what? Root bridge. So a spanning tree, let me put question mark here. What we can say, a spanning tree, then is there any option for priority? No. Let me say VLAN 1. For VLAN 1 I am doing for right now, right? In the same way for all VLAN also you can do it. Let me say priority what? 0. Priority 0. Now guys, if I will up this interface, E0/0 interface, what will happen? This attacker will send superior BPDU to switch number 2, and on switch number 2 this port will become what? RP. But now if you will check again the switch 1 spanning tree, you can see, so a spanning tree here 0/0 and 0/1, these two interfaces are what? DP, designated port, correct, correct. And here we are not able to see 0/2 interface because line protocol of this interface is down. For now, here I'm going to say no spanning tree, for VLAN 1. I have disabled the spanning tree for VLAN 1 for now, right? As we are running PVST, so it is maintaining a separate instance for each VLAN. Now I am going to up interface E0/0 here, say no set, right? So soon line protocol will come up, and after that on switch number 1, if you will run so spanning tree protocol, just wait, so interface status, oh, 0/2 interface is actually disabled, means shut down manually. So here you can see this port is up, that's why you are not able to see this port in a spanning tree, right? So manually here also I have to run no set command on E0/2 interface, say no set, right? Now so a spanning tree, yes brother, see 0/2 interface is what, your DP, designated port. But once I will enable a spanning tree protocol on attacker switch, once I will enable a spanning tree protocol on attacker switch, a spanning tree for VLAN 1, right? It will send BPDU, superior BPDU to switch number 1, and on switch 1 will receive superior BPDU on 0/2 interface. This port will become what, RP, right? So for now, switch 1, make sure you are clear with these all terms, like switch 1 is your root bridge. Here you can see this term, this bridge is the root, and all ports of this switch is RP, all ports are RP. Now I am going to enable a spanning tree on attacker, and now guys, here if you will run this command, you can see this port is your what, RP, root port. And now you can see this switch is not root bridge. Now which switch is root bridge? Switch who have this MAC address, and this is the MAC address of attacker. So now attacker switch is your root bridge switch, right? And this port is DP on all switches, like on switch number 2 also, on switch number 3 also. You can verify on switch number 2, enable so a spanning tree, you can see which switch is root bridge, switch who is using this MAC address. And guys, this is MAC address of attacker only, right? You can see the MAC address of switch 1, the actual root bridge switch, fine. So to prevent this attack, we have what guys, root guard. Now again, what I am going to do, I am going to disable a spanning tree protocol from here, say no to this from attacker switch, and again let me check a spanning tree. Yes, now you can see on switch number 1, let me access switch 1. Yes, on switch number 1, again you can see, just wait for some time. Soon this switch is going to become root bridge switch. So convergence is slow, right? Because here we have not configured any features to make it faster, so that's why convergence is slow. But after max's time, this switch is going to become again what, root bridge switch. After 20 seconds, you can see now these all ports are what, DP port, and again this switch is what, root bridge. This time guys, I'm going to enable root guard feature on 0/2 interface E0/2, and here I'm going to enable root guard feature. So what command I will run? A spanning tree, what is command? A spanning tree root guard, switch 1, a spanning tree. I think, is there any option for root guard? Guard is there, guard, and then root. I think this command, right? Now this root guard feature is enabled on E0/2 interface. Now what will happen if the attacker will send superior BPDU on 0/2 interface? So a spanning tree, you can see these all ports are DP, and this switch is my root bridge. Now again I am going to enable a spanning tree protocol on attacker switch. Let me do one thing, let me run command a spanning tree for VLAN 1. Again it will send superior BPDU to switch 1, and this time guys run so a spanning tree command. You can see this interface is in blocking state now. Because of what? Because of root guard feature, right? And you can see switch have put this interface in root inconsistent state. This is similar like blocking state, and still this switch is your root bridge switch. You can see this bridge is the root, right? So still switch 1 is your root bridge now this time. Why? Because of root guard features. So root guard feature should be enabled on all the switches, on all the DP ports of root bridge. For now, see, okay, root guard feature is enabled on E0/2 interface, right? So if this switch will receive any superior BPDU on this interface, it will put that interface into root inconsistent state, and it will not allow this port to become RP. So still this port is what? Your DP port. Still this port is your DP port, designated port, right? And switch 1 is your still root bridge switch. What will happen if switch number 2 is going to send superior BPDU? Because root guard feature is not enabled on this interface, guys, right? So again, same thing will happen. This port will become RP and switch 2 is going to become what? Root bridge. So that's why I'm saying root guard should be enabled on all interfaces. Like see, on switch number 2, if I will set priority 0, spanning tree, VLAN 1, and say priority what? 0. Now again you can check the switch 1 spanning tree. You can see 0/1 interface is what now? Root port. And again this switch is not root bridge. Which switch is root bridge now? This switch. This is MAC address of switch 2. Now switch 2 is your root bridge, right? So root guard feature should be enabled on 0/0 also, right? Again from the switch number 1, I'm going to remove this command, say no to this command, and after 20 second topology is stable. Wait, yes, no, still RP. After 20 seconds you will see this switch will become again root bridge and this port will become what? DP. Yes, now you can see this port is DP and this switch is the root bridge. Fine. So what I will do simply here on all the interfaces, interface range E0/0 to 2. Here I am going to run a spanning tree guard root. Now root guard feature is enabled on all the interfaces, right? And so a spanning tree. Fine guys, you can see this port is still in blocking state, right? Root inconsistent state because attacker is sending superior BPDU on 0/2 interface. But here if I will run this no spanning tree for VLAN 1, if I will disable the spanning tree protocol over here, what will happen? It will stop receiving superior BPDU from this interface. So just wait for some time. So interface status error disable. Okay, yes. So a spanning tree. Now you can see automatically this port is in listening state now, right? After some time this port will come in forwarding state. Why? Because now this switch is not receiving any superior BPDU over here. So same thing I have mentioned in theory. You can see root guards adds an extra layer of protection to STP network by guarding against unexpected root bridge change caused by, okay, here, where is that point? Yes, here it is. Prevent it from participating in the forwarding process until superior BPDU stop, right? So now superior BPDU is stop on 0/1 interface, so that's why this interface comes in forwarding state. Now you can see my STP topology is now stable, right? So if this attacker is going to send superior BPDU, nothing will happen, right? Spanning tree VLAN 1, nothing will happen on the switch. Only switch 1 is going to put this interface in inconsistent state. That's it, right? Still switch 1 is my root bridge. So this is concept of, guys, root guard. Now hope it is clear to you. Say no. Okay, leave it for now. Again, if I will remove this spanning tree from here, this port will come in forwarding state after 20 seconds. Okay, so hope guys root guard feature is clear to you, like why we are using it. We are using it to protect the root bridge. How? We will enable this feature on all DP port so that it will not allow DP port to become RP port. right? And whenever a DP port will receive superior BPDU and root guard feature is enabled there, then switch will put that interface into root inconsistent state, which is similar like blocking. Okay, then the next feature is what? Loop guard. So guys, loop guard is for, you can see here, the loop guard works on non-designated port. This feature is for RP port or for alternate port, right? Not for the DP. So root guard is used to protect what? DP port. Definitely it is used to protect root B switch, but where we enable it? On the DP port. But loop guard is for RP port and alternate port. So you can say what? This or the loop guard works on non-designated port. Non-designated port means your RP port, root port, or your alternate port. It does not allow the port to become what? Designated. So RP port should be always RP, alternate port should be always alternate, right? So to prevent this type of problem, or this type of to achieve this type of protection, we are using what? Loop guard feature. So to protect RP and alternate port. So this feature will not allow a port to become designated port. Like guys, in my scenario, and let me read some more paragraph over here. Loop guard is a feature in a spanning tree protocol STP designed to prevent the loop in situation where the normal spanning tree protocol mechanism might not be sufficient, where normal STP is not working fine, let's say, right? It specifically addresses the issue of, this is very important, unidirectional link failure, right? Guys, actually we are using these features for, optical fibers. Let's say in between switch 1 and switch 3 we are using what? Optical fiber. This is optical fiber cable, right? So in fiber cable you will have two ports, right? You will have two ports. One is for transmission and one is for receiver. One is transmission, one is receiver. One port is receiving the data, one is transmitting the data. So guys, this port is what? Your RP port, right? That means it will always receive the BPDU over here. Okay, but let's say in the optical fiber, TX port or RX port is not working fine on R3, or TX port is not working fine on switch number 1, right? So this switch is not able to transmit anything from this port, but RX port is working fine. So what will happen in this scenario? Switch 1 is going to send superior BPDU from their both port, but as TX is not working, right, it will not forward superior BPDU to switch number 3. Earlier switch 3 was receiving superior BPDU, so that's why this port is what? RP. But this time it is not receiving any BPDU on this port. Then what will happen? Switch 1 will forward BPDU to switch number 2, switch 2 will relay that to switch number 3, and again switch 3 is going to relay that BPDU to switch number 1, right, from the TX port, because TX is working fine on switch number 3. So if switch 3 is not receiving BPDU on this port, then switch 3 will forward BPDU from this interface, and once this port will start forwarding BPDU, this port will become what, guys? DP from the RP, right? This port will become DP from the RP. So just to protect this, we have what? Loop guard. So if you will enable the loop guard feature on this interface, then what will happen? Then loop guard feature will not allow this port to become what? DP, designated port from the RP. So this port will be always what? Alternate port. Another scenario, let's say this is my alternate port over here, alternate port, right? So alternate port is sending the BPDU from here, right, and is receiving BPDU as well. Like switch 2 is also sending BPDU on this segment. Getting my point, guys? So let's assume this alternate port is receiving superior BPDU. If let's say this link is not working fine, then what will happen? Switch 3 is going to receive superior BPDU on this port, alternate port. So this port will become what? RP. That is fine. That is whenever this type of change will occur, then this port should become RP, right? But just assume when this link will goes down, or not this link, just assume like this. So how we can create the scenario? Let's say this is alternate port, and this port should not become what? Designated port. When this port will become designated port, when it will forward the superior BPDU from there, from this interface. Getting my point? Right now switch 3 is receiving superior BPDU on this interface, right? Superior BPDU on this interface, one BPDU on this interface and one BPDU on this interface, right? And switch 3 is sending BPDU as well on this interface, right? On this link. But the receiving BPDU is the superior as compared to the sending BPDU. But if the BPDU which switch 3 is sending, that is superior. Let's say switch 3 is not receiving any BPDU from switch number 2. Again here TX port is not working fine, right? So switch 2 is not going to forward BPDU. Then switch 3 is going to forward their superior BPDU from this interface, right? And once this interface will transmit superior BPDU, this port will become what, DP, right? So again loop guard will not allow this interface to become what, DP from the alternate port. So this is guys feature for unidirectional link failure. When one link TX or RX will goes down, one pin will goes down, in that kind of scenario how you will prevent the loop, right? So see, in the spanning tree network, in the STP network, in the loop free topology also loop can form, right? So as I told you, let's say TX port is not working fine here, so switch 1 is forwarding BPDU to switch number 2, switch 2 is forwarding to switch number 3, right? And as switch 3 is not receiving any BPDU over here, it will relay that BPDU to switch number 1. So this is what guys, loop, temporary loop. Switch 1 is sending BPDU and same BPDU switch 1 is receiving on their other interface. This is what, one temporary loop. So to avoid this type of loop, we have what, loop guard feature, right? And to enable loop guard feature, what command you will run? If you want to learn more, read more about the loop guard, you can read it guys here, like when a switch port stop receiving BPDU from its neighbor, it might transit into a forwarding state even though it is not receiving expected BPDU. If this happens and there is a unidirectional link failure, a loop could potentially form in the network, and loop guard help to avoid this situation. Loop guard monitor the BPDU on root port and alternate port. You will enable this feature on root port and alternate port, and after enabling it, this feature will start monitoring root port and alternate port. If loop guard does not receive BPDU on root port or alternate port, if it will not receive the BPDU, it put the interface in loop inconsistent state. So always keep in mind your root port, RP or alternate should always receive what guys, BPDU. Okay, if it will not receive BPDU, it will start transmitting BPDU, and if it will start transmitting BPDU, then port will become DP, right? So that's why we have this feature, that whenever these two types of port will not receive BPDU, it will put that interface into loop inconsistent state, preventing it from transmitting the forwarding state until BPDUs are received again. Okay, this helps to maintain a stable and loop free network even in the presence of unidirectional link failure. And command is what, this one, command is this one. So on all DP port and RP port we should enable it. So guys, in my topology, on switch number 1 I don't need to enable this feature. On switch number 2, should I enable it? Yes, because on switch number 2 we have one RP port, right? This is RP and this is again DP. So on DP we are not going to enable it. On this port you can enable root guard feature, right? But on RP you have to enable what, loop guard feature. So on the RP port, switch to interface E0/2, and before that, if you want to perform this lab, like you can see in my topology, this switch number 2 is receiving superior BPDU over here, right? And it is transmitting that BPDU from this interface. Let's say if I will down this interface, then what will happen guys? Switch 3 will stop sending BPDU on this interface. By the way, it is not sending BPDU because this is alternate port. It is only receiving the BPDU, right? So let's assume that if I will down this interface, then what will happen? If I will down this interface, it will not receive BPDU on 0/0 on RP port, and it is receiving BPDU on 0/1 interface, on this interface, right? 0/1 interface, and then switch 2 will start transmitting that BPDU from 0/0. So this port will become what, DP, right? So to prevent this, what we need to do, we need to enable here what, loop guard feature. To perform this lab, simply what I can do, on switch number 1 I can down 0/0 interface. So see, if I will down 0/0 interface here, config t interface e 0/0, say shutdown, right? For now let me run no shut command, and let me verify you the switch 2. Here is switch 2. See, so a spanning tree, right? 0/1 port is what, guys? Your RP port. 0/1 is what? Your RP port. But when 0/0 of switch 1 will goes down, right? When I will run shutdown command over here, then 0/1 port will become what, DP on switch number 2. Now if you will run this command, just wait for some time. After some time you will see this port will become what, DP port. I've shut down the interface. Yes, you can see now 0/0 is what, your DP. But this port should be what, RP, right? Here we need to troubleshoot the network, that why switch 2 is not receiving BPDU on 0/0 interface, but this interface should not become, guys, DP. This interface should become what, RP. Because now see, now if this interface is DP, that means it is sending BPDU to switch number 1, and this is what, loop. So still we have loop in the topology now. So just to prevent this problem, what we have, loop guard. Here again I am going to run no shut command. So after running no shut command here, this port will again become what, RP. Yes, you can see now this port is RP. And now I am going to enable loop guard feature here. Interface e 0/0, say a spanning tree guard, and then loop. That's it. I've enabled this feature over here, and now show a spanning tree. Correct. This port is RP. Now again I am going to down this interface on switch number 1, means 0/0 of switch 1. So it will stop sending BPDU. And now on switch number 2, let me show you the spanning tree. Just wait. See, guys, this port is still what, RP. Now this port is not going to become what, DP. Why? Because loop guard feature is enabled over here. 0/0 is in now blocking state. Yes. So this port is a DP port, but it will not transmit the BPDU because this port is in loop inconsistent state. Status is what, blocking. So this port will not forward any BPDU from here. So even though I think on the real devices it will not become DP port, designated port, but okay, leave it. If this port is becoming DP also, then also it will not transmit the BPDU. Debug a spanning tree events. BPDU receive and transmit. Yes, you can see this switch is, let me on all and see from the here, these are the log messages. STP on which interface? On 0/1 interface, it is receiving BPDU. Is it sending any BPDU from 0/0 interface, guys? No, it is not sending any BPDU from 0/0 interface. And if you want to check the only transmit BPDU, you can debug a spanning tree BPDU transmit, right? See, the switch is not sending any BPDU. because loop guard feature is enabled on E0/0 interface. Again, if I will disable loop guard feature on 0/0 interface, E0/0 spanning tree guard loop, and say no to this command, it will start transmitting. You can see the BPDU from 0/0 interface. And so spanning tree. This port is DP port. Why this port is DP port? Because this interface is down, right? So it is receiving BPDU over here and is transmitting from this interface. So this port is DP. Now we have disabled the loop guard feature over here, right? So that's why it is, this port is DP, and now it will send, it will transmit the BPDU from E0/0 interface. It should generate logs. This is simulation, that's why we are not able to see, I think, logs here, right? But it will generate log message, and it is transmitting BPDU from 0/0 interface. So guys, that's why on switch number 2 on E0/0 interface we should enable loop guard feature. That's it. On switch number 3, on which interfaces you should enable loop guard feature? On switch number 3, on RP and alternate port. Means this is RP and this is alternate. On this both interfaces, loop guard feature should be enabled, right? So let me take you to switch 3, and on switch 3 also I'm going to enable it. Interface range E0/0 and E0/1 spanning tree guard loop. Fine, right? So now my spanning tree network is stable. We have configured root guard also, we have configured loop guard also. Now the next feature is what? Next feature is BPDU guard. Guys, BPDU guard is used to protect your access port, right? These two features is for trunk port, right? Between switches, link between switches, but BPDU guard is for access port, like on the port where your end devices are connected. You know, BPDU, what is BPDU? BPDU is a message in a spanning tree protocol which need to exchange between switches to maintain a loop free topology, right? Switches need to exchange BPDU, that's it. But a access port means port where end user is connected, right? This port should not receive any BPDU. If this port is receiving any BPDU, that means again guys, there is some loop, right? So if let's say one attacker will connect their device here and they is going to send BPDU, he is going to send BPDU on the access port, right? Again, what will happen if this BPDU is superior BPDU, right? This port will become, guys, what? RP, right? And this switch will become what? Root bridge. So to protect this problem, we have what? BPDU guard. BPDU guard is going to filter BPDU. Is going to filter BPDU. Let me show you the definition of it. BPDU guard. Here you can read. BPDU guard is a feature in a spanning tree protocol that helps prevent network disruption by detecting and responding to unexpected BPDU. Right? BPDU are messages exchanged between switches in a network to establish and maintain the loop-free topology created by STP. Very good. True. BPDU message need to exchange between switches only, right? So when a BPDU guard is enabled on switch port, it monitors the incoming traffic on that port. If the port detect any incoming BPDUs, if port is detecting any incoming BPDU, it assumes that there is a potential loop in the network caused by unauthorized or misconfigured device. In response, BPDU guard automatically put the port into error disable state. And to solve it, you have to shut down the interface and then you have to run no shut command again. BPDU guard is typically used on ports where end user devices are connected, such as your computer, printer, are expected to be connected. It helps maintain the integrity of STP topology by immediately blocking ports that receive unexpected BPDUs, because we are not expecting any BPDU on access port, right? On access port end devices are connected, guys, so which are normally only generated by switch. This rapid response helps avoid network loops and enhance the overall stability of the network. And command to configure it is what? This one. Spanning tree BPDU guard enable. Spanning tree BPDU guard enable. So what I am going to do in this scenario, let's say on the root bridge switch, this is my access port. 0/2 is my access port. Access port. Now this is end user and machine. Let's assume this is attacker. What if this attacker will generate a superior BPDU over here? Guys, first of all, on switch number 1, whatever features I have enabled on 0/2 interface, I am going to remove the configuration. Interface is 0/2. Say default, then what? Default interface, default Ethernet 0/2. Ethernet, I think I need to run this command in global config mode. Default interface Ethernet 0/2. Right now it have set the default configuration on 0/2 interface, correct? So you can see root guard feature is disabled. Fine. Now this port is your access port. So spanning tree 0/2. I think 0/2 interface is down. Interface, yes, 0/2 is here na, correct. And one interface is down, that is 0/0. Let me run no shut command here. Interface is 0/0. Say no shut command. Fine. So a spanning tree. Now you can see 0/0 is your DP port, degenerate port, and this is access port, guys. So what if this access port will receive a BPDU? This access port should not receive any BPDU, but as there is one attacker, if attacker is going to generate a BPDU over here, what will happen? Again, this port will become what? RP port, and attacker switch is going to become what? Root bridge. So let me do one thing here. I'm going to set priority 0. Config T, spanning tree, VLAN 1, priority 0. Again on switch number 1, you can see your this port is what? RP, and now this switch is not root bridge. Again attacker is root bridge, right? So to avoid this problem, like if you are not expecting any BPDU on access port, right? As you are not expecting any BPDU on access port, you can configure BPDU filter over here. So once you will enable BPDU filter over here, it will start monitoring this interface. Whenever it will detect any BPDU on this interface, it will put this interface into error disable state. So what I am going to do, first from the attacker, I am going to remove a spanning tree protocol. A spanning tree VLAN 1, say no to this. I have removed the spanning tree protocol, guys. And now again after 20 seconds, you will see this port will become more DP. Yes, now you can see this port is your DP port. Now I am going to enable BPDU guard feature over here. Command is this one, spanning tree BPDU guard enable. So let me take you to switch 1. Go to interface E0/2 and say spanning tree BPDU guard. That's it. BPDU guard, and then I think enable. Correct. Got it? Now, so spanning tree. Now again I am going to enable a spanning tree on attacker device. Say a spanning tree for VLAN 1. It will send the superior BPDU, and now you can see here the log message. It have put the interface into disable disable mode, right? So spanning tree, you can see this port is removed from here 0/2 interface, and so interface status error disable. You can see there is one interface 0/2 is in error disable. Reason is what? BPDU guard. So we have put this interface in error disable BPDU guard. Getting my point? So guys, this feature should be enabled on your all access ports, so that your access port can never receive a BPDU. Doesn't matter which BPDU, any BPDU, it should not receive any BPDU, right? And guys, if you will disable the spanning tree from the attacker, switch say no spanning tree VLAN 1, even though this interface will be still in error disable state. To correct it, simply you have to run shutdown command and no shutdown command. Interface E0/2 says shutdown and then say no shutdown. That's it. And so is spanning tree. Now you can see this interface is in listening state. Soon it will come in forwarding state. DP. For the faster convergence, what we can do? We can enable the port fast feature here, right? Interface E0/2 spanning tree port fast, and so is spanning tree. Now you can see this port is in forwarding state. If you will down the interface again, interface E0/2 shutdown and say no shutdown, it will come in forwarding state quickly. You can see this port is in forwarding state. So on your all edge port, on all access ports, port fast feature should be also enabled, so that as we are not running a spanning tree protocol on edge ports, so edge port should come in forwarding state quickly. Then guys, last feature is what? BPDU filter. So see, what is BPDU filter? BPDU filter, again, BPDU filter is used to stop BPDU on access port. As a spanning tree protocol is running, right, on all the ports, on switch number 1, you can see a spanning tree protocol is running on all the interfaces, right? So if you will debug a spanning tree BPDU and let's say transmit, so you will see this switch is transmitting BPDU from their all interfaces. Why it's not showing the log? Debug spanning tree events. This is simulation, that's why I think it is not generating the log message, but you know, switch 1 is sending BPDU from their all interfaces, like switch number 2 is also sending BPDU from this interface also, but it should not send BPDU from this interface because here PC is connected, right? PC don't need to do anything with BPDU. PC don't need BPDU, right? Because we are not running STP between switch and PC. In the same way, switch 3 is also sending BPDU from this interface. So just to filter this BPDU, to filter BPDU on edge port, we have what feature, guys? We have BPDU filter feature, right? So when BPDU filter is enabled on a switch port, the port neither send nor receive BPDU. This effectively isolates the port from participating in STP process. So this is similar like, you know, disabling a spanning tree protocol on edge port, on access port. So on a port, if you want to disable the spanning tree protocol, you can configure BPDU filter. A BPDU filter configured interface never send BPDU or never receive BPDU. It is important to note that enabling BPDU filter on the port can lead to the network loop if not used with, cause BPDU filter is typically used in scenario where STP is not required, correct? When port is connected to a non-STP aware device such as what? Server, PC, routers, like that. Let's say one switch is connected with one router. Let's say here I have one router. Switch 1 is connected with one router. right? So again guys, between switch and router we are not running STP, so here we should disable the spanning tree protocol. So what we can do, we can enable the BPDU filter feature, right? And command to enable BPDU feature is what? This one. Port fast BPDU filter default. So on switch number 1, on my access port, interface is 0/2, I'm going to enable a spanning tree, port fast BPDU port fast. So I think this command is not acceptable in simulation, you have to run it on real devices only. Port fast, and before port fast BPDU filter is there, right? BPDU filter, this command, and then enable like this. So now BPDU filter is enabled over here, so it will not transmit any BPDU. For now what I'm going to do, I'm going to just capture one link, right? Because guys, debugging is not working here. So just to show you that switch 2 is transmitting BPDU from their 0/2 interface, I'm going to capture the link. Let me capture it. Which port? 0/2 interface, which is connected with PC. And here I'm going to filter STP. See, it is transmitting STP BPDU, but if I will enable BPDU filter on switch number 2, so a spanning tree 0/2 interface na. Also go to interface is 0/2 and say a spanning tree BPDU filter enable. After running this command, it will stop sending BPDU. See, now it is not sending any BPDU. Now it is not sending any BPDU from this interface, right? And even it will not receive any BPDU on this port. So you, on your all edge port, what features should be enabled, guys? Let me revise. On your all edge ports, these two features should be enabled: BPDU guard and BPDU filter. Even you can ignore BPDU guard, but BPDU filter should be enabled on all edge ports. On all DP ports of root bridge, root guard feature should be enabled, and on all RP and alternate port, loop guard should be enabled, right? So in my topology, see, this is my root bridge switch, right? This is DP port, this is DP port, this is RP port, this is RP port, and this is again DP port, this is alternate port. So see, on these two interfaces, what features should be enabled? Root guard. On this port, what feature should be enabled? Loop guard. On this port and this port, what feature should be enabled? Loop guard, right? And on your edge ports, which features should be enabled? BPDU filtered. So hope now STP protection is clear to you. But again guys, if you have any question regarding STP protection, you can let me know in the comment section. Definitely I will make another video on it. Thanks for watching, guys. If you have learned something from this video, please hit on like button. If you have not subscribed my channel, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye. Thanks for watching. That's all for today.